Let us discuss about the refractive index. Refractive index. When we studied the laws of refraction, we come across this thing, refractive index, and the definition is what it tells about the material or the pair of materials, because in refraction we take two materials. This is the boundary of material. Let this will be a glass bar, a rectangular glass piece. This is air, this side, and this is glass bar. This is the boundary of the glass and the air. Now let a light ray strikes here obliquely. This is an incident ray, and this being the normal. And this light ray, due to refraction, don't follow its incident path in the glass. It bends sometimes, because glass is, this is the glass G, this is the air. So glass is optically denser as compared to air, so it bends towards the normal. This angle be R. Say this is incident angle I. So second law of refraction, Snell experiment established that there is a relation between I and R, and he found that sin I upon sin R is constant for what? Is constant for a given pair of material. Means here the material is air and glass for a pair. For refraction, we need the boundary of material. We need two materials. So this is a constant. We denote it with n. And generally, if in case of air, let first be air, second be glass. Then what is A and G? Refractive index of glass, second material, with respect to first material, with respect to air. A and G means sin I upon sin R. There is also a relation between the velocities in two mediums, velocity of light in two mediums. Now, a very conspicuous, notable thing you should know, the light ray is incident along this line, and if it goes in this line, it would have emerged here. यहाँ आके बाहर निकलती. If there had been no deviation, would have been no deviation, then it will follow this path. अगर कोई deviation नहीं होता तो ये लंबा रास्ता चुन के यहाँ पे आती. Now the speed of light here, V air, it is 3 into 10 to the power 8 meter per second. In glass, Vg, it is 2 into 10 to the power 8 meter per second. So what happens? Take a general idea. I am giving you just for your general knowledge. This ray deviates in this way. Why? The velocity becomes less in the glass, and it has to cross this material glass, so it follows the lowest path, minimum path. So this distance is less. This one is less as compared to this point to this point. This is O, This is, you take it B, and this is B dash. If there had been not this glass, so the ray would have gone in this way. एयर यहाँ से जाती है, अगर रे यहाँ से जाती है तो इसको लंबा रास्ता ओ बी डैश, ये लाइन ओ बी डैश इज ग्रेटर देन ओ बी. क्यों? क्योंकि यहाँ पे ये इसके अलॉन्ग जब रिफ्रैक्टेड रे ग्लास में मूव कर रही है, व्हेन इट इज मूविंग इन द ग्लास, इस वेलोसिटी बिकम्स लेस 1.5 times. So it tries to follow the small path, so it bent towards this. Then how will you explain the term n in respect of the velocity of light? Here it was found glass ka refractiveness with air, it is 1.5. So here there is also a relation n is equal to V air, VA upon VG. Here it is 3 into 10 to the power 8, and here it is 2 into equal to 10 to the power 8. It is again 1.5. The velocity of light in first medium and divided by velocity of light, ratio of velocity of light in first medium to that of second medium. The n of G with respect to A is this much. This relation is also established that refractive index is the ratio of velocities in the two mediums. Let us take some questions so that theory may be clear. A beam of light passes from air into substance X. A beam of light passes into a substance X if the angle of its incident be 72 degree and angle of refraction be 40 degree. What is the value of n, refractive index? You have to calculate the refractive index. This is the boundary, this is glass, this is air. So now this is boundary of the two materials. This side is air, this side is glass. Let this strikes at 72 degree. From the angle is always taken from the normal. This is n. Now what happens? This is deviated towards the normal, refracted. After refraction, they follow this path. So this is 40 degree. This is 72 degree. Now, as per Snell's law, a second law of refraction, n. N of what? N of G. Now, here one thing more. Air is taken as a reference. So, when we talk about the refracting index of a material, if the first material is air and second is glass, then it is called the refracting index of the glass. You can add with respect to air, refracting index of material second with respect to material first. But in generally, air is taken as a reference, so we called it Ng. So this is velocity, this is sine 72 degree, 72 degree divided by sine 40 degree. The values are given 0.953, 951, and it is given 0.642. If you calculate, it will become 1.5. 48, just equal to 1.5. For glass, generally this value comes into picture. Thus we can calculate the refractive index. Now, some more questions. Now we have seen the relation of velocity of light in a pair of material in reference of refractive indices. Now one more question. Light enters from air to glass plate. There is a glass plate having refractive index 1.5. What is the speed of light in glass? Oh, very good. Now take this one sine formula is 1. N is equal to sine I by sine R, and it is velocity in air and velocity in glass. The first material is air, medium is air, and second medium is glass. So this is also true. Here the question is, एयर से ग्लास में इंटर कर रही है, तो व्हाट इज द वेलोसिटी ऑफ लाइट इन ग्लास? तो वी नो इट इज गिवन, refractive index is given, it is 5. This material is glass, this Ng is equal to 1.5. So apply this formula, Ng, or you write sometime Ang. First one is air, second is glass. So Va divided by Vg. It is just mathematics. 1.5 is given. Here we know that 3 into 10 to the power 8 meter per second. And we have to calculate velocity of light in glass. So Vg is equal to 3 into 10 to the power 8. Simple mathematics divided by 1.5. It is 2 into 10 to the power 8 meter per second. It is very simple, but when you will solve the numericals, it will be clear, the concept will be clear. Now one more question. If the refractive index of water for light going from air to water be 1.33, air to water, refractive index is always given for pair of medium, दो मीडियम. तो बाउंड्री पे रेफ्रेक्शन होता है, तो रे deviates at the boundary and further it follow the straight path. The rays always, the light travels in the straight path. But what happens in refraction at the boundary of two materials, when the ray strikes traveling from one medium and reaches the boundary, at boundary it changes its direction and further it follows the straight line. So this air, this side water. Let this is the pond, this is the top surface of water. What happens? Here it says refractive index of water for light going from air to water is 1.33 given. ANW it is given. Water ka 1.33. Now one thing more. Refractive index is the ratio of two things. Ratio of velocity or ratio of sin I by sin R. Sin का ratio है, या ratio of two velocities. V1 by V2, this is N, 1 and 2. So here is meter per second, here is also meter per second. So this N has no unit. This is just a number. N is just a number, this has got no unit. no meter, no kg, no second, no unit. This is just a number. So this is water refractive index is given 1.33. What will be the refractive index of light going from water to air? Now, this is the case. This is N. This is the case. This is air. So this is the case when the ray coming from air and after refraction traveling in the water. Then this is. It says that if the direction is reversed, if light goes from water and strike at this point and then emerges in the air, what will be the refractive index? Now here the refractive index will be, in this case, W से water से जा रही है, तो here A. So now it is given A and W is given, so this will be 1 by N. तो यहाँ A और W, इसका opposite हो जाएगा Y. This is I, this is R. In first case, when this is coming here and this is going here, so what A, this one, A and W, this will be sin I by sin R. And what will be this one when it will follow this one? So here we will take incident angle will be this one and refracting angle will be this one. So in case of W and A, it will become this angle, sine of first one. If it starts from here, then first medium will be this, so sine of R and divided by sine of this angle. Of name, we take same name. So this will be 1 by NAW. So here naturally you will calculate WNA. It will be 1 by 1.33. This is simple mathematics. You calculate and you will find out what the value will be. It will be nearly 0.75. Now, some interesting questions. The speed of light in air is such 3 into 10 to the power 8. In medium X it is 2 and in medium Y it is 2.5 into 10 to the power 8 meter per second. So you have to calculate air दिया हुआ है, air का, and then there are two mediums. Okay, given VA, velocity of light in air, it is 3 into 10 to the power 8 meter per second. Now also given there are two mediums X. This is X. It is given 2 into 10 to the power 8 meter per second. And Vy is given 2.5 into 10 to the power 8 meter per second. It is very simple. Now you have to calculate Nx, Ny, and you have to calculate, you have to find out A. air N and X. Number B, you have to find out air NY, A N Y, and C, you have to find out X N Y. Means refractive index of X with respect to air, refractive index of Y, substance Y, with respect to air, refractive index of Y with respect to X. Now very simple, you have read the formula N, refractive index of medium 1 with respect to 2. You have read the velocity of first divided by velocity of second. You put these values, when you find out this, so here the velocity of light in air divided by velocity of light in this X, here velocity of light in air, the velocity of light in Y, and here velocity of light in X and velocity of light in Y. All things are given. This is simple mathematics. You put this divided by X here 2 for this one, and AX 3 into 10 to the power 8 divided by 2 into 10 to the power 8, it is 1.5. Here second case, ANY 3 into 10 to the power 8 divided by 2.5 into 10 to the power 8. You solve, you will get the answer. In this way, here X and Y velocity in medium X and velocity in medium Y. Velocity X 2 divided by 2.5. This is 2 divided by 2.5 to the power 8 and to the power 8. They will cancel. You solve this one, very simple. Solve this one, very simple. You will get the answer. This is just mathematics. The concept should be clear, fundamentals should be clear. Now one more question, and then we will touch today the refraction of light, the image formation by the convex and concave lenses. But one more question. The medium, two medium are material. These medium and these are value of N, refractive index. This is A, this is substance A or medium 1. It has got N, value of N. N means with respect to air 1.33. It is B, the value of N with respect to air, it is called absolute value of that medium. For example, glass, so Ng, if first one is there, then it is 1.5. So this is absolute value of the refractive index of glass. First medium A ka 1.33. In this case means medium A is second medium, first one is air. And B is 1.44 C 1.5 2 and D is 1.65. Now question is, in which of these four media is the speed of light? Number one, question is speed of light. The speed of light in these mediums. Which of these mediums? Number one is maximum and number two is minimum. Now you see, the greater the value of refractive index, the more denser is the medium. The medium will be more dense. Higher the value of n, higher will be the optical density of the medium. So, and the higher the optical density, lesser the speed of light. So first of all, we see which medium is less denser. We have to find out maximum velocity. Speed of light is maximum. So V maximum किस में होगा? All the four substances, all the four medium, which is very less dense. So less dense means lowest value of n. So this one is 1.33. So the medium A. V maximum will be VA. Velocity of light in A will be V maximum. A में यहाँ maximum होगा. Minimum opposite of this. Denser, optically denser the medium, lesser will be the speed. D. So V minimum में V minimum, this will be D. Any VD, velocity of light in D will be the minimum. So here minimum होगा. One more question, the last question. The last question of high thinking. A very good question. The following table gives the refractive indices of few media, few substances: water, crown glass, rock salt, ruby, diamond. Let us denote by, say, this is water and this is 1.33, crown glass, this is 1.52, and rock salt, this is 1.54, kala namak, ruby, you have seen, you have idea, 1.71, and last one is diamond. It is 2.42. The refractive indices are given. Use the table to give an example of. The question is, now, question means a question. These values of refractive indices are given. The question is, a medium pair, दो medium आपको चुनना है, the pair of medium, show that light speeds up when it goes from one of these medium to another. एक से जब दूसरे में जाती है तो लाइट की स्पीड बढ़ जाती है। अब लाइट की स्पीड किस में बढ़ जाती है? व्हेन द स्पीड ऑफ लाइट इज हायर द मटेरियल इज रेयरर, डेंस मीडियम में कम होती है। इन द डेंस मीडियम, ऑप्टिकली डेंस मीडियम, स्पीड इज लेस, ऑप्टिकली रेयर मीडियम, स्पीड इज हाई। सो टेक two medium, one having the value of n is lesser value and one is greater value. So this is diamond is the greater value, and here the water is the having the very less value or low value of n. So when if you take this one, this is the water, here the water is filled up, and here this is the diamond. Now it's the value of n is equal to 2 point. The speed is very slow. These are water. N is equal to 1.33. When you compare these two media, this is upside is diamond, this side is water. So when the light rays goes from this water, this is the normal, this is I. This is very denser, optically denser as compared to this. So what happens? Here the speed will decrease too much. This will bend, having the high value of n. The refracted ray will bend at the boundary here or towards the normal. So this is the opposite case. So what is our question? The question is a medium pair so that a light speeds up when it goes from one medium to another medium. So we have got the opposite case. Now let us find the let the light rays coming here striking at this point. This is the normal. We know that speed of light in the diamond will be very less because diamond is optically denser, densest, सबसे ज़्यादा dense है, optically more dense, and this is optically rarer as compared to diamond. So when it strikes here, I with the normal, it will go away from the normal because it is rarer. So this will follow this here, this part. In this speed will be W and this speed will be D. So what is N? W N D diamond. This will be speed of light in air, and here is speed of light in diamond. How will you find out from these two values? These are given absolute values. N means, N water means A N W. This is 1.33, and this diamond means A N D. It is 2.4. So how will you find this W and D? You will find W and D. D is on this side. So you put A N D divided by A N W. This will become this. So this is A N D 2.42. This is 1.33. When you solve it, 1.9 के आसपास आएगा. So you see here, this will 1.8, let it will approximately 1.8 this ratio, and W and D will be 1.8. So 1.8 will be VA divided by VT. 1.8 No, no, not VA, not VA, VW. W and D है तो VW first medium velocity यानी V1 by V2, VW by VD. So VW, the velocity of light in this we find out VW is equal to 1.8 VD, 1.8 times लाइट की वेलोसिटी होगी वाटर में एज कंपेयर टू डायमंड. And the second question is a medium pair of medium so that light slows down when it goes from one medium to another. You can find many, you can make many pairs. For example, water less the crown glass 1.25. The velocity of light when compared in water and crown glass. The velocity of light in water will be more as compared to that of in crown glass. When you compare the crown glass with ruby, the velocity in ruby will be less, in crown glass will be more. In rock salt and diamond, in this way you can calculate. We have taken the highest values and lowest values of n. So this is the answer. If you reverse this, the light traveling in water, it seems not, this is the direction, then this will be in this direction, away from the norm. This will be the original direction, this will not follow the original direction, this will be the R. Okay, in next class we will be discussing about the convex lens and concave lenses and the image formation by these lenses. Okay, thank you for today class.